Jim,
Hello,
Jim.
Celine. How? Jim.
Sorry, I was in a meeting. Yeah. Are you, what are you doing?
Doing amazing. Yeah. I was in the Google invite, like the meet, and I was like, I don't think this is the right place. And then I checked the invite.
Oh, yeah, my bad.
It
Let
was
me remove
no, it was
that.
me being retarded. I'm like, we've never met on Google Meet before
Yeah.
that I remember, so I should have remembered that.
Yeah, it's
But
my
I
fault.
figured it out eventually.
That's okay. I removed that. Um, okay.
It's like a bad habit.
Yeah, literally. All right. Um, okay. Just I will put a message, sorry, to say we are live. Let me take a screen. Oh, a note taker. What the No note taker. No, no, no. Uh, yeah. It's the rule with me. No note taker. Um, okay. Let's go. Classroom attendance, yeah, I will put that. No worries. Tac, tac. Telegram. Ah, foo, 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 foo. So I selected 100 people um, for the course. Um, wait. We are live. Up. Look. Let's start in like yes, 1 minute. Mm.
Perfect. Yeah.
Up.
Hope everyone's doing well.
Looks okay. Yesterday they were quite exciting to start. So
Nice. Oh, okay, so you had a session yesterday. I was wondering if you guys, because you said you were going to make a 2 hour thing.
yeah,
So I appreciate, yeah,
yeah. Yesterday, in fact, I was thinking like 2 hours was too much. So yeah, I've done like a session, an introductive one about DevToolBack itself, and yeah, it's more an important session to make sure everyone is on track with the program. And yeah,
awesome.
all right. So. I think we can start. Yes, before everything, like if you can share your story, as usual, would be a great
The
thing
drill, yeah.
for everyone.
I know the drill. Yeah. Perfect. Yeah, I can. Yeah. Thank you so much for having me as always, Celine. It's great to be here. I really love these sessions because I get to meet new people and yeah, help people get into the space. And I can tell my story, which is always pretty awesome. So I got started. I actually was working for a Web2 company called NGINX. I'm sure probably some of you have heard of NGINX, web server, reverse proxy, and I was really interested in Ethereum because mostly because the price was going up, and that was like my signal, like, hey, we should probably pay attention to this, which is so silly to think, but I know a lot of people come in the space because of that. And I started learning about smart contracts, and I started learning about Solidity, and I went online and I found a lot of videos from Austin Griffith, who is the creator of scaffold-ETH, which we're going to talk about later today. And it kind of became an instant like fanboy, and like really started diving into like Ethereum. And I actually got started in the space by doing photography. So I would go to hackathons, I would go to conferences, and I would shoot photography for fun as like volunteer. And then I would kind of like meet people. And it was my luck that I got to meet Austin Griffith in person. I got to meet Kartik, emailed Kartik and said, hey, I'd love to shoot photography for all the ETH Global hackathons, which ETH Global is like a really big hackathon company, I would say, in the space. And he hired me as a contractor to shoot all the events. And at the same time, I would shoot the or perform the workshops for scaffold-ETH. So all by still working at Nginx too. And then eventually I left Nginx and started working for the Graph protocol. So my journey was like very much like hustle mentality, like trying to get things done. But it's just it's funny how like there's this kind of magic that can happen when you just like make connections in crypto. So my advice to everyone is just keep pushing forward and keep learning, and you'll achieve great things. So yeah, so I work in DevRel for the Graph. So I support all the engineers in the Graph protocol. And I also kind of do DevRel for Build Guild, basically, one of the core members that support them. And I also have my own community tool for hackers called Genesis, which I'll probably talk about at some point too. But yeah, I'm doing a lot in the space, and I have a passion for education, and so I help out here with the Dev3 Facts sessions. I think this is my fourth one. I can't remember, but it's been a while. And Celine's amazing. She's doing such a third, yeah, third, yeah, okay. So I'm very excited to help you guys out. And I think without further ado, we can just kind of dive into it. That's enough about me. Feel free to answer questions as we go. Oh, that's awesome. Someone knows Yash. Yash is a great guy. Um, yeah, so thank you so much. I don't know if I met some of you in New Delhi, but yes, I was there as well. It's good to see you if I did. But yeah, let's dive into it. I'll try to keep an eye on the chat, and then let's go ahead and share my screen. So I did share a link to the, let me minimize this.
But by the way, I put
So
the
there we go.
recording of the session on Google Classroom. Yeah, right now we are using Google Classroom to follow up everything properly, and so
Oh,
you can
amazing.
all
Okay,
check your attendance there.
cool. Yeah, make sure you fill in your attendance. Cool. All right. So the notion here that I outlined is kind of what we're going to go over today. We're going to focus on the intro to blockchain and building on Ethereum. And there might be some homework here. I'm not sure if I think we were going to skip the speedrun Ethereum challenges, but if you want, it's kind of like stuff you can do. It's kind of just like up to you. I think if you want to do it, is that right, Celine? I don't know what if you have like checkpoints for people. Well, we can figure it out when we get there. Okay, so yeah, I talked a little bit about myself already. Uh, what you'll learn in this kind of series is like the basics of Ethereum and specifically the Ethereum virtual machine. And you'll also learn a lot about wallets, a little bit about accounts. We'll do a session on Solidity and what smart contracts are. We'll also teach you about scaffold-ETH, which is a toolkit for building on Ethereum. You'll also learn how to utilize what are called React hooks and components for scaffold-ETH. If you're not a front-end developer, don't be afraid. We're gonna like show you how easy it is to build on Ethereum with scaffold-ETH's hooks and components. And there's just some general links here that you guys can go and learn on your own async, like Introduction to Ethereum, Introduction to Scaffold-ETH. The docs page is really good. There's a docs page that has all of the documentation. And then there's some videos that you can watch from Austin as well as the slides to be able to see like what is going on in the space and like what to pay attention to, especially with Ethereum. So we already talked about me. All my socials are here. If you have any questions, I'm an open book. Please feel free to message me. My Telegram is here. That's the best way to get a hold of me. I'm not as much on Discord, to be honest with you. But please, yeah, follow my socials and feel free to email me. That's another option as well. I generally am more likely to see emails in my work email, so send those or Telegram. So, okay. So we'll get started here. I think the goal is to maybe talk to you guys and do like a lecture for maybe 30 minutes, maybe less, and then try to actually build like a very basic app with scaffold-ETH and show you how easy it is. First of all, if you haven't like built on Ethereum at all, it's fine. There's a really good presentation or a rewatch of this presentation as well in here that you can watch from like the another session I did with some college kids that might be a little bit more thorough, I would say, and you can always watch that asynchronous. But I think before you like start building on Ethereum, you need to kind of understand what it means to like build in a Web3 way. I know like Web3 is a little bit of a buzzword, but it really is like just all about the evolution of the web and like where we've come to, right, to this point, and like what we're trying to achieve in like this sense of Web3. you have to kind of understand like the previous kind of iterations of the web, which I think probably a lot of you guys have a Web 2 background or like some familiarity with that stuff. But really, it's just the concept of decentralization, right? Going from the fact that we have like these standalone servers that can do, complex operations, they can run programs, there's databases and all this kind of like cool infrastructure that we've evolved to this day, but it's all private, like most of it is like people running these servers behind firewalls and protected and very much closed in that sense. Yes, there's like open source, but it's not like open data and open access. A lot of APIs are, consumed. You have to pay for them. Twitter API is a great example. Like it's super expensive, and to be able to get access to all that data because they know that it's like very like useful data. And so like Web3 is this concept of like trying to like break that apart, right? Trying to like make everything decentralized as much as you can, right? You can't decentralize everything in a perfect like cypherpunk dream, we can. But I think the idea is to try to break up the app layer more specifically and maybe some of the infrastructure into smaller components that can be distributed across the globe in a more open way. And so this is done with like peer-to-peer technology. And I would say that the most common thing that you need to understand with Ethereum is it's the most robust, powerful like blockchain to be able to do that type of thing. It's got the most adoption. It's got the most advanced developer tooling. It's got the best developer communities. And so that's kind of why Ethereum, I think, is poised to be, a really good tool for the future if we can like build things in the right way on it. So that goes to the next question, like why should you build on blockchain? And really that comes down to not only the fact that Ethereum is a decentralized network and it has lots of participants that are already very highly engaged in it, like DeFi and people providing stake to the network to secure it. But more importantly, the concept of programmable money, like creating a smart contract, right? A smart contract is the power of blockchain. And the fact that for Ethereum, you can execute these smart contracts, and these smart contracts can have special rules that allow you to really build like decentralized APIs essentially that are living forever. And really, if you design something in the right way, it can live forever on Ethereum blockchain. So this really cool concept of smart contracts is definitely the future. And this is all powered by a lot of different things. One of the most important things that you should probably understand at some point is asymmetric encryption if you don't already understand it. So you can come here and there's a good video that kind of explains it. But that is really what powers a lot of the blockchain technology that we have today. And some of the values of actually building on blockchain is that you get some cool stuff out of that, right? You get zero downtime. When you have decentralized network of nodes, there's always going to be one node up and running, right? And so this gives you that zero downtime. There's privacy baked in as well. You can basically generate a key on your laptop within seconds, and you can utilize that to make transactions. So in that sense, it's open and in some ways private. Obviously, there's some other things you should consider for privacy, like there's other ways you need to mitigate privacy. It's also resistant to censorship. So anyone can run a node, right? Like it's not like, hey, you have to have like a signature on something or you have to have access. Anyone can open it. And then you also have this concept of data integrity because a blockchain is that it's a chain of blocks. And so each particular chain iterates on itself and gets better and better integrity as it gets better. Because if you change anything in the previous, then you're there. You also have this verifiable ability where you can verify everything that's happened on the blockchain, and it makes things trustless. So there's a lot more introduction about blockchain that you can kind of go into more. Like, and we're kind of just kind of skim the top and give you guys a good primer for like the rest of the course. And you can kind of dive in. All these things are like different little sections. This is a really good video that is actually from Vitalik, the founder of Ethereum, that talks about why Ethereum is useful. And it's actually just a very basic explanation, but it's still very relevant. It's kind of funny how it's aged. It still works really well. And so what is Ethereum, right? Ethereum is one of the most, I would say, adopted blockchains that we have, right? Sorry, my son is out here. One second. Okay, so my son might be in here just sitting here, just so you guys know. All right, so what is Ethereum? So Ethereum is a blockchain, but I think the superpower that Ethereum has is what's called the Ethereum virtual machine. And the Ethereum virtual machine is what allows smart contracts to execute in this like special way and be able to create this programmable money, right? This programmable way that you can do essentially execution. EVM is just one giant computer in the sense that all of the Ethereum nodes are operating together to work together to act as like a single system, right? And so just like we have Bitcoin has BTC, Ethereum uses ETH, and it's quite simple. Like you have some application that you want to deploy to the blockchain. So you as a user, if you want to access that application, you probably do something through a web application. Use some kind of like framework like Web3.js, Ethers.js, or VM or something like that. And then you either have your own node that you run, so you have your own Ethereum node that you run, or you go through someone else that has a node and they provide it for you. So there's providers that do that. So Infura, Geth Geth is the standalone binary that you can download, so you can run Ethereum on your laptop. And then that is what gives you access to the blockchain. And you can deploy smart contracts, you can interact with smart contracts, you can send value using that RPC provider or that RPC connection, I guess you would say. And you do so on Ethereum through what are called transactions. So similar to how you have HTTP, where you like make an HTTP call and then you get back a response. It's a very similar thing. It's a message-based system where you basically are sending in a transaction that is signed with like a private key. And if that transaction is accepted, it updates the state of the blockchain. So you can imagine like a blockchain has a state. It has a world state, and then it has like account states inside of it. And so if we think about like the world state, like the world state could be like a string is equal to hello world or something like that. And then you could update that string, and it's not going to change until the next block is created, right? And that transaction is finalized. And so when you make a transaction, you're like changing the state and then putting that into the next block, and then it gets finalized, right? And there's lots of different things that go into, I'm probably simplifying it a lot more, but that's generally what you need to understand is that you're signing transactions, you're sending in some value of into the transaction, maybe for like transferring value or paying gas, and we'll get to that in a little bit. But really, that's really what happens is we have this transaction that happens. And so again, this is done with messaging. So you send a message call into the blockchain essentially, and you do this with like a private key and a public key. So you have a private key that is like your password. You don't want to share that. And then you have your public key, which is your like public address. And those are a pair, right? And so you sign the message with your private key, and then you put in all the instructions of what you want to do, and you pay some gas. So you'll learn about this concept of gas with Ethereum, but really you're just trying to provide power to the network essentially to execute your transaction for you. Because when you're executing on the blockchain, all of the nodes are executing your transaction. Let me stop for a second, see if there's any questions here. Sorry, my chat's acting up. 1 second here. Okay, so it looks like we have one question. Can you shed some light on public-private and what does a non-custodial wallet mean? Yeah, so a public, I think I kind of briefly touched on it, but a public key is like your address, right? It's like what you give people so that they can send you funds. It's kind of like your unique identifier, and it's actually generated from your private key. And the private key is kind of like, again, it's your password, and you can take your private key and you can like generate you have a mnemonic, which is like your passphrase that you might when you first set up like your wallet, and you can generate uh, private keys from that mnemonic, and they can be stored. So you can have multiple private keys for one mnemonic. So when you set up a wallet, you set up your like, it's like eight, I forget what it is, eight different words, 12 words, sorry, that you generate. And then that's your like kind of like seed phrase. And then you generate these private keys from that seed phrase. And so you can have lots of them inside of one seed phrase. And this is all done using cryptography. And then when you say custodial wallet, so that this is a wallet that you own, right? Like this is not a wallet that is on like Coinbase or on whatever exchange. Like there's a lot of centralized exchanges that will give you a wallet, Robinhood or whatever, and these are like wallets that they hold custody of. But when you hold custody, you hold your private key, and that's what's important. So it's important you don't share that key or that phrase with anyone. Write it down. If you do want to share it with someone, it needs to be someone you trust in there. And so, yeah, so the next question is gas is basically payment for a transaction. Yes, essentially. So what happens with Ethereum is if Ethereum gets really like over complicated, like over populated, like just lots of transactions coming in, there's a special mechanism in Ethereum that makes the gas price increase slowly as the more transactions come in. So if it gets busy, the gas price will go up and up and up and up. And so what the gas price is a multiplier of like how much money you need to pay to execute a transaction. So you can go online and look like gas tracker or like whatever for Ethereum, and you can see it. And if like I said, the network's really busy, that gas price will go up. If the network is very slow, the gas price will go down, and it's kind of this automatic mechanism. And yes, you need to pay this gas essentially to execute because you're paying a little bit of gas, and everybody in the entire network needs to run that process for you. So if you're trying to change a 1 to a 0, there's a certain cost for that. If you're trying to run 1 plus 1 times 10, then there's an extra cost for that because you're having to do multiplication. So there's these like different operations that you'll learn about. They're called opcodes. You probably won't go that deep in this course, but opcodes have a certain gas price and you have to pay for those things to be executed. What's cool is the wallets handle all that stuff for you, so you don't need to worry about it. You just click on the button and it will figure out what the gas is. There's kind of like a standard gas limit. And the way it works is if you send a bunch of gas in the transaction, and you don't use it all, you'll get back the gas you don't spend. So it's kind of like a refund mechanism. And again, the gas is all pretty much managed for you. The only situation is if you don't send enough gas, the transaction will fail and you won't get any state change. So there are some like caveats. This is why you need to write your smart contracts to be the most gas efficient as possible, which again, we'll get to that later. And you can see here where the refund is. Okay, so let's keep going. So here, this is an example world state. We transfer from one state with a bunch of transactions in that block to make a new state. So it's pretty simple. And every time there's a new block, so with Ethereum, there's a block every like 10 seconds. With Base, there's a block every like 2 seconds. With I think Optimism or Arbitrum is almost down to a second now or something. I can't remember, but it's pretty fast. And so we're starting to see blocks being formed faster, but it is important to understand that all a block is a bunch of transactions that are finalized and then saved on the blockchain. By the way, there's a really cool app. It's called ETH.build that is created by Austin. And this is an embedded video that talks about transactions. And ETH.build is this visual way for you to like explore and mess around with blockchain transactions. It's really cool. Watch that in your downtime because it's like mind blowing and you'll like really understand how transactions work from a much more fine grained level. Cool. So I think generally speaking, we kind of addressed what Ethereum is. Looks like there's another question. Hi, please have a question. Do we write message calls with smart contracts? So a message call is done through a transaction to a smart contract. Okay, so or to the blockchain itself. Like if you propose a transaction and you provide all of the source code in bytecode into the transaction and do a create, it will create a smart contract for you. So that is a transaction itself, and you're making that to the blockchain. in the sense of like if you're interacting with a smart contract, yes, you're making a call or you're making some kind of transaction into that smart contract. Like you, and we'll show it off here in a sec. You'll see what I'm talking about. But just like Python and JavaScript and TypeScript have functions and variables and all that stuff, smart contracts also have that. And so when you're making a call to a function, or if you're like, calling a function and then something else needs to happen, these are all things that happen and take up a certain amount of gas in the transaction. So, any other questions before I dive into scaffold-ETH? And this will be, I think that's a good primer. And now you'll like see us actually build something, and you'll kind of see how like you don't really need to know all that stuff right away. You'll come back to this and learn it later as you kind of go along. And scaffold-ETH is going to abstract a lot of that stuff away and just help you to start building. So yeah, let me know if you guys have questions. I'm going to go ahead and get started here with this next section. So what is scaffold-ETH? So scaffold-ETH is a starter kit. It basically comes with like everything you need to build an application on Ethereum. It comes with a front end. It comes with a chain that you can run locally. It comes with some hooks and components. It comes with a burner wallet, which is cool. It comes with Wallet Connect, so you can hook up to your like wallet on your phone. It's got a lot of cool stuff. It's also got a lot of boilerplate code written for you, so you don't have to like start from scratch and just build everything before you even get started with your smart contract. So it really just lets you get started really, really quickly. And so, yeah, we'll talk about what a burner wallet is, but a burner wallet is basically a wallet that is something you don't really want to use like to store lots of money. Like it's like a wallet you just want to use for development purposes, really. And so scaffold-ETH has this in-browser wallet, and we'll show it off. Yeah, so I don't know about in the sense of like Sepolia. Sepolia is a faucet for like a test net. We'll get to that in a second. But test nets are like for like if you want to just like send a contract to a test net, you can kind of test it out and see if it works before you actually pay real money on the main blockchain. In terms of airdrop, I'm not sure. I don't know what that is, but yeah. Okay, so let's talk about scaffold-ETH. So if you go to scaffold-ETH.io, you'll see this main page here, and you'll see that there is a docs page, and there's a GitHub page for it, and then there's this command that you can run to install it. And in order to install it, you need Node.js installed on your machine. You also need to have Yarn package manager because it's a Yarn repo. And that's pretty much it. And Git. If you want to use Git, you'll probably need to use Git, which you probably already have. So all you need to do is run this command right here. So we can copy it, and we can go ahead and do that. So let's go here, and let's make it a little bigger, and let's run that. Okay, so it's npx create-eth at latest, okay? And what we're going to have here is it's going to ask us to install the newest version of create-eth. So create-eth is the script that helps you set it up. It's a kind of this choose your own adventure thing, and it lets you start a project. So we'll say, what do you want to name your project? And we'll call it dev3pack. And it's going to ask us what framework we want to use. So we can use Hardhat or we can use Foundry. If you're new to blockchain development, I always recommend Hardhat, especially if you're like coming from a world of JavaScript, because all of the testing is in JavaScript and all of the deploy scripts are in JavaScript. It's just easier. If you want to be like the cool guy and use the most cutting edge thing that's fast, then Foundry's for you. I don't really think it matters too much. I personally like Hardhat because I've just been using it, and I don't know, I'm just stuck in my ways. So I'm going to use Hardhat. Now, this is going to scaffold out a project, and it's going to create two folders. So it's a mono repo, which means that you have more than one project inside of your repo. And one is for your front end and one is for your back end, which is the blockchain. And it's going to set up Next.js. It's going to set up React, obviously, with Next.js. It's going to set up the chain you chose, all of the packages that you need to interact. It's going to install everything. And then it's going to format all the files so that they look pretty, so they're typed properly. And then, formatted properly. And then it's going to initialize like an empty Git repository for you just so that you can start building. So One thing I'll say is you need a couple windows open to get started with scaffold-ETH. You need a window for your chain. You need a window for your front end, and then you need a third window, a terminal window, for like typing in like commands to deploy. Okay, so when it's done, you'll get this thing that says, "Congratulations, you're ready to go," and it gives you the commands to do. So it's going to tell you to go into the dev3 pack folder, and then it's going to ask you to run yarn chain. So, and then the next one is yarn deploy and yarn start, which we'll get to in a second, but let's go ahead and do that. So what I'm going to do is I'm just going to open up some other commands here, or some other windows. Sorry. So again, you need multiple windows open. So this first one is your chain. You can see it gives you these like private keys we talked about earlier, and it gives you a public key that matches each one of those. These are for like, if you want to use the ETH, maybe you want to import it to a wallet somewhere. So you'll see those, you'll know it works when you did that. And then I'm going to open up another window and go into the same folder, right? Dev3 pack, and I'm going to do yarn start this time. So yarn chain brings up your chain. Yarn start starts up React. So now I have my chain running and I have React running. Now in this very last window here on the bottom, I'm going to do yarn deploy. So starts up your front end, chain on your blockchain. Deploys a smart contract that comes with scaffold-ETH to your blockchain that you're running locally. So you can see here that we got a successful output, that it was a call made, and we can, if we go up here, we can look and see what it said, but it said that it deployed and sent a transaction, and it mined the block, and then it was successful. So we successfully deployed our contract. We also see out down here that we get some deployment output. We see what the address is, and we see how much gas it costs too. So it costs 532,000 gas basically. And then we get some like console output. Okay, so what did that do? Well, it looks cool here, but let's go ahead and start it up in our browser. So let's go to localhost 3000, which is right here, right? This is where our React is running. And what this is going to do is going to bring up scaffold-ETH for us, okay? Now, let's see if there's any questions while we're waiting. Yes, it will automatically run yarn install for you. Yep. So yarn install is one of those commands that just installs all the packages. It does that for you when you run npx create ETH. Oh. After creating the project, CD project, yarn deploy, yarn start. So yeah, so after you create the project, go into the projects folder and do yarn chain first. So first bring up your blockchain, yarn chain, then open up a new window and go into the same project folder and do yarn start. Then open up a third window, go into the project folder and do yarn deploy. So it's yarn chain, yarn start, yarn deploy. Okay, yarn deploy. Yep. Yeah, don't worry. You can watch the replay. And I think all the commands are actually in here. So if you follow here, right now we're using just regular scaffold-ETH. The commands teach you about using scaffold base. Sorry, I forgot that, Celine. We can actually do that too as well if you want at some point, but maybe we could do that one of the later sessions. But scaffold base is a special branch of scaffold-ETH that comes with everything base. And so, but actually scaffold-ETH comes with base support anyways, so it doesn't really matter. We'll actually deploy to base when we deploy. Okay, okay, so when we see scaffold-ETH comes up like this, and you might see this, that you're on the wrong network. So just say disconnect or something like that. And you'll see that you'll get this beautiful UI. This is what scaffold-ETH is. Scaffold-ETH comes with a like basic UI written for you. So all this is kind of just like hello world stuff. This debug contracts is where the real power of scaffold-ETH is. And the reason why this is powerful is we didn't get too much into it. We're going to dive into more tomorrow. But when you create a smart contract, you write it in a high level language called Solidity. And we're going to look at it here in a sec. But as you start making changes to the Solidity, and then redeploy it, you deploy the bytecode onto the blockchain, which is like just numbers and like unreadable. It's like unhuman readable. And so in order for your front end to really know how to interact with the contract, it needs what's called an ABI. And what scaffold-ETH does is it takes the ABI and it generates this UI for you using all types. So these are all type safe. And so these are like UI components that you can interact with and just start interacting with your contract. So we can see already right here that we have a contract that's called your contract. It has no ETH in it. It's on hard hat, which is what our chain we chose. And it has a string and it has an owner and it has a Boolean and a counter. And it has the ability to update the greeting. So right now it's set to building unstoppable apps. I could say hello dev3 pack, and I could try to send it like this. Hit send. So this is where I'm actually trying to send a right transaction, and it's going to give me an error. It's going to tell me that I don't have enough money to pay for gas, right? So how do I fix that? Well, there's a faucet right here on the top, and I can get some funds, and I can hit send. So what's cool is I didn't need to connect my wallet. I just had this browser wallet that came with it. I was able to fund it here with this little button and give it some play ETH. So now I have like $4,600, which is 0.9999 ETH. And I was able to update the greeting to dev3 pack. And I got a transaction receipt, which is like when it comes back from the blockchain, it's your receipt. Okay, let's see if there's some questions. Does it make sense initiating scaffold-ETH in an existing Next app? No, you should use an empty folder because it's going to fail if you try to do that. Okay, faucets. Yeah, so like here we have a faucet that is built into our app that just gives us a bunch of ETH from Hard Hat or from Foundry, depending on what you chose. So you see, I just click it because it's a local faucet. And when I click it, it's sending me ETH. So if I click this right here, here they are. They're coming in. They're sending me transactions. So it allows me to just have fake money to play with, to like toy around because, you know, smart contracts require money to interact with them. So just like you're deploying locally, you might need to deploy to a test net. And so there's also test net faucets. So if you were to do a search for like Sepolia faucet base, you'd be able to find the base Sepolia faucet. And there's like a list of them, which Alchemy has some, Third Web, Coinbase has one. Superchain. There's all these different faucets you can use to get play base ETH, which is base Sepolia. But it is so cheap actually now to deploy to a base mainnet that you can also just deploy to base mainnet. It's really up to you. Okay, so let's take a look. We've kind of messed around with the UI here. Let's load up like what scaffold-ETH looks like inside of the code editor. So I'm going to use Cursor. So if you're not using Cursor, I highly, highly, highly recommend that you guys use it because it's got the AI components, super powerful. It's going to help you guys a ton building. Make sure you're using something like Cursor. There's also Claude Code. There's some other ones that are good for like AI. VS Code might have some extensions as well. But I would just, Cursor is probably the best. Okay, so now here we have, let me see if there's another question real quick. Cool, looks like people are good. Cool, all right. Oh, what's the difference between VM, WAGMI, and Ethers.js? Yeah, so the question there is we'll get to that in a little bit. We are using VM and WAGMI. It's a little bit newer, I guess, more popular right now. Like Ethers was very popular for a while, but there were some limitations and there were some like performance problems. And so we switched to VM and WAGMI a while back. It's just because everyone was, and it just kind of became the more popular choice. So it's really just about, I guess, choice. Okay. All right. So let's look at it here. So we have the packages folder. And if we go into the packages folder, there's a hard hat folder and there's a Next.js folder. So today we're not going to go into the Next.js folder really at all, probably. We're just going to focus on the hard hat folder. And inside the hard hat folder, there's a contracts folder. And inside there is your smart contract, okay? So what you'll see here is that we have this contract that is a very basic smart contract. We'll get way more into Solidity as we go further along. And you guys will probably have some extra breakouts just on Solidity. But what's important to know is that this contract is already pre-writ for you. Everything that we see here is what is in here, but in code, right? So if we wanted to let's just add some functionality to it right now. We don't need to go into the details, but there's a function called set greeting. There's a withdraw function. There's like an ownership pattern. There's like a bunch of stuff in here. But what I want to do is just change something. So let's make a new address string, or sorry, address called public, called boss, like this. And then let's make a function that allows us to set who the boss is. So function set boss. Let's make it so anyone can do it. And that's it, pretty much it. Yeah. So all we did right here is we created a new variable called boss. And then we created a new function call right here that lets us set who the boss is. Anybody can call it. It's public. And it will set the boss to whatever's passed across in the function. So it's an address called boss. If I save this and then come over here and deploy again, I'll get a new contract. I'll get a new smart contract, okay? If you ever want to like force a new contract to be deployed, you can do yarn deploy -- reset, and that will force a new contract as well, okay? And so what that does is it's going to deploy a new contract for you to interact with. So if we come back to scaffold-ETH and refresh, well, it's already refreshed, we have a new variable called boss. And you can create as many variables as you want. You know, you can do string, public, hello, equal, hello, save it, and then deploy again, and you'll get that. It will show up here in your variables. So any second now, it's going to refresh. There you go. There it goes.
If it's
There
the
it goes. Now we have this string.
to tell. Because
Sorry, is there a question?
no, just like I was mentioned, if it's like going too fast, don't hesitate to tell you. Because
Yeah,
it's
for
very
sure.
new for them. Like for example, someone asks you what is like a faucet, etc. So
Hmm. Yeah, perfect. Yeah, thank you. I appreciate Paloma. Thank you for hopping in. Yeah, let me know if I'm going too fast or if I need to clarify anything for sure. I know I talk fast, so.
no,
Okay, so here we have. Hmm?
no, I was saying no. It's just like it's a new concept for them, so that's why. For me, it's okay.
Yeah, yeah, no, no worries. Yeah, no, yeah, for sure. If anyone's in the audience and needs me to repeat anything or rewind, I think this is more of like a flash thing where like, hey, you see all this stuff happening, and at first you're like, oh wow, it's kind of like confusing, but it's cool, and now I want to learn. And so you'll realize that like I'm not going to be able to teach you everything in an hour or even 3 hours. It's a journey that you need to go down into learning. And scaffolding tries to make it as easy as possible for you. So, okay, so we've gone in here and we've
uh,
made a change, right? Hmm.
Someone asked, can you
Another
please show
question.
that once again, like the code part boss function one?
Yeah, yeah, sure. So if we come here to the smart contract, which again is in packages, hard hat, contracts, your contract. And if you come in here, you'll find an empty, well, not empty contract, but the everything you see inside of the debug contract tab. And then I just added an address called boss, and then I added a string for fun. It's getting hello. And then I just made a new function here that's set boss. So again, just like any programming languages has functions and variables, we have the same thing in Solidity, right? We have the ability to set something or change something. And in order to do that, you interact with it with a transaction. Okay. So you should have this kind of like, once you get to a point where you can like kind of toy around and make some changes, we're not going to do anything crazy because I don't want to go too far down the rabbit hole of Solidity right now. I really just want to show you like how cool scaffold-ETH is. So if we come to the home page here, this is like the root of the application, which I think we're going to have Celine, remind me, are we going to have a front end one for this, or will
Yeah,
we
yeah,
cover
yeah.
front end stuff?
It's gonna be
Yeah,
the last one.
cool. Okay, so we'll go into a lot more detail on Next.js. But what I want to show here is that let's just say we didn't want to change anything. We just have this smart contract we wanted to deploy now. Let's say we want to deploy it to base. Okay, I'm going to deploy this to base. How would we do that? Because right now we're doing everything on our local laptop. So what I want to do is I want to deploy it to base. So I'm going to do yarn run generate. And what that's going to do is it's going to generate a private key for me on my laptop inside of that folder, in the dev3 folder. And it's going to ask me to put a password on it. So you should put a password here. I'm just going to hit enter because I don't want to put a password in. And it's going to generate a wallet for you. So it's going to generate this address, and it's going to put the private key and encrypt it on your machine so that people can't get into your laptop and steal it. Then we can do yarn account, and we get like a QR code. Okay. So enter, put your private key. There we go. So now we get a QR code for it right here. So now what I can do is I can take my phone and I can open up my wallet, and I'll scan this with my phone, and I'm going to send just $1 of base ETH on mainnet, base of mainnet. So this is $1, review, and send. Okay. So I just sent with that QR code to my laptop. I got the address, just sent it through Rainbow, and we'll just give it like 2 seconds, and then we'll run the account again, and we'll see if we have a balance now. So it's going to ask us for the password. It's going to go through and check all the balances, and hopefully when it gets to base, it's going to say that I have 0.00. It is right there. So I have 0.0002168 ETH on base mainnet. So now this deployer key, so again, just like you need a deployer to interact with, you need a private key to interact with a smart contract, you also need a private key to deploy and create a contract. So what I'm going to do is when I do this yarn deploy, I'm just going to do -- network base. That's it. So I'm just going to deploy this contract to base, which is really stupid because it's useless contract, but that's okay. We're just showing how easy it is. So now it's going to create a transaction. It's going to send it to the blockchain, and it's deployed. I just deployed a smart contract to base. And if we grab the address here and we load up base scan, let's load it up. So base scan is a block explorer that lets you like kind of see what transactions are happening. I can put that address in here, and there it is. It was deployed. If we look at the contract, it's all gibberish. So remember we talked about bytecode? This is what the bytecode looks like. It's just numbers and letters. It's unreadable. So how do we clean that up? Well, what we can do is verify our contract as well. So because we're the authors of the contract, we've already deployed it. It's right here. Now we can verify it so that other people can see it. All we have to do is do yarn verify -- network base like that. So I deployed the contract to base mainnet. Now I'm verifying the contract by sending, and what happens here is I'm sending a copy of my source code to Basescan. They're compiling it, comparing it to what's on the actual blockchain, the bytecode, and then they're seeing that it matches and verifying it. So now it's verified. And so if I come here now and refresh, we can see the contract code that I wrote. Here it is, string hello, address boss, and we have this like set greeting, and then we also have the set boss, right? And so that's cool. We basically deployed a contract super fast to base. We verified it. It's verified. Now what? Well, now we want our front end to point to base. So right now it's pointing to hard hat, right? So if we go into scaffold-ETH and we go to the Next.js folder, there's a special config file called scaffold config, which is right here. And it lets you choose what chain that you want to use. So there's lots of chains, right? There's, I don't know, hundreds of blockchains that are EVM compatible. And so if it's in VM, you should be able to update it here. VM is the SDK that allows you to interact with the blockchain. And so all we need to do is put chains.base, okay? And it's all type safe. So you can see here, like it searched for base and it saw all the different bases. So base Goerli, base Polia, base. So we just want normal base, and now we'll save it. And what will happen is you'll see here that it will change. We'll get kicked out of our burner wallet. So burner wallets are not secure. Like you don't want to use them on a main net, right? You don't want to use them on like Base or Ethereum or Arbitrum or Optimism because the private key is stored in the browser. Burner wallets are just for testing. So at this point, we want to connect a normal wallet. So we could connect our phone or we could connect to MetaMask. So I'll just connect to MetaMask here. Now we've got this app. I'm on the wrong network. It tells me to switch to Base, which is really nice. So it's going to switch me to Base. Here's my wallet address. And now if I go to debug contracts, I can become the boss. So I can see set boss. And actually, I'm going to set Vitalik.eth to the boss. Hit send. And now I'm proposing a real transaction with real money on the blockchain. And I just paid like 0.01 cents or something to make Vitalik the boss on my smart contract. Okay, so this is just an exercise to show you how easy it is to, and there might be something wrong with my MetaMask here. I might have to speed this up. I don't know why. Aggressive, submit, speed up. There we go. Let's try it again. There it is. So now Vitalik is the boss, yeah? I think. Or did someone, yeah, there it is. Vitalik is the boss. Okay. So in that little short period of time, I just did a very basic smart contract, deployed it to Base, verified it, changed my front end. The very last thing that I could do is I could deploy my front end as well so that you guys could interact with it. And I could do that in a couple ways. I can do Yarn Vercel, which will use Vercel to deploy my front end, or I can do Yarn IPFS, which should work. Let's try it. IPFS is called the Interplanetary File System, and it's like a decentralized file share protocol, essentially, that allows you to deploy assets to IPFS, which is like a decentralized network. And so you can take your front end, and what it will do is it'll compile down your front end into static files. And when you run Yarn IPFS, it will publish it to the Build Guild IPFS. So we run our own IPFS server, and you can just store your front end there. Obviously, it's not good for like production stuff. You probably want to use your own like IPFS service, but the Build Guild one is free, and you guys can use it, and it will pin it for you as well. And so I think I'm not going to get too much into that, but basically when you pin something, it stays on IPFS for a while. Okay, so I want to be respectful of everyone's time, and I know we have like 7 minutes, so let me take a look at the questions while this is deploying. We'll come back to that in a second. Okay, npx created the latest. Yes, that's the right command. Will it work in Windows? You need to use WSL for sure if you're using Windows. I'll take a look at that error in a second. Do we need to always create a private key like this to deploy on mainnet? Either you'll need to create a private key or you'll need to import your existing one. It's a lot easier just to create a new key because you can just fund it really easily. Like you saw how easy it was for me to just create a key and then fund it. You probably don't need to deploy to mainnet. You can deploy to base Sepolio. So we talked about chains, faucets. You can also deploy to base Sepolio. So if you were to do like yarn deploy -- network base Sepolia like this, then it would deploy to base Sepolia, which is a test net and it's free. You know, you can just get some base Sepolia ETH. I can send you guys some if you need it. Just let me know. I know Celine has some as well. Just let us know. And then we can see here that it looks like it was successful. Yeah, so now our app actually is deployed right here. So let me share that in the chat and you guys can go to it if you want. But basically, here it is. There it is. So now our app is on fully decentralized, really. We have a decentralized contract. We have a decentralized front end, and we can connect our wallet here. And that's pretty much it. It's working. Okay, let's see what other chat questions we have. One second. Those steps should be in Notion. Let's see what's in there. I'm trying to remember what I have you guys do in the Notion. I kind of just have you deploy a contract. I just show you where to go to edit stuff. I don't really show you how to make changes, and I don't show you how to deploy it, but I always like to show this in the first session because this way you see the full like cycle of when you're building an app, so that you're just like it's a good primer. I'm not expecting you guys to be able to do everything I just did right now, but at least you should be able to have scaffold-ETH open to make some changes to it. Use AI if you want to make some changes, whatever. The deploying and stuff like that, that's kind of just extra. I just wanted to show you how it's done, so that you know. Let's see what other questions here. These does it accept base names? Yes. Yeah, it should accept base names. So you have this concept where you type in an address here. If you saw on the last session that I do with you, I'm going to show you a lot of the components that have resolution. But you saw that I wrote vitalik.eth, right? And what it does is it tries to resolve it into the address. So these are called ENS names. There's also base names. And it supports both because base names are ETH names. So if you were to do like Vitalik, see Vitalik.base.eth, maybe, let's see. That should also resolve to Vitalik because they probably gifted it to him. Let's see. Oh, that doesn't resolve, so it's a reserved one. Okay. But yeah, you can use any kind of name then. How did you speed it up? Oh, that's a good question. So I have some kind of issue with my MetaMask, and I always have to come in here and speed up the transaction because there's something wrong with my gas settings. So your wallet should not do that. There's just something wrong with my wallet, and I don't know why it's doing it, but it's been bothering me for a while. I need to just reset MetaMask, and I just haven't had a chance to. But on the transaction, when you click on it, there's a speed up button. The reason I had to speed it up is because I didn't send enough gas when I first sent the transaction. So imagine when you send a transaction to the blockchain, you're actually sending it to what's called a mempool, which is basically a big list of transactions. So you don't want to like send your transaction and then like send another one until that other one's done. So what you do is you send your first one, and then if it doesn't have enough gas, like in my case, you just send more gas, and then it sends more gas in another signature, and then they kind of go together, and then the transaction executes. So that's why you saw me do the speed up button. I just sent more gas into the transaction. How did you set Vitalik.eth? So yeah, I just typed it in and it will resolve it. Thank you everyone for helping with the chat, by the way. Cool. People are actually deploying. This is great. How do you redeploy with a hardware wallet? I don't know if you can do that I don't know if you can do that easily with like Hard Hat or Foundry. There's got to be a way, but we're talking about like, I mean, unless you're deploying to Ethereum mainnet, which is a little more expensive. Most people are deploying stuff to layer twos these days, and it's not much, doesn't cost much. I don't think you need to use a hardware wallet, to be honest with you. Guys, in case anyone needs notes, cool. Someone's taking notes. Thank you. How can I get base Sepolia? So base Sepolia ETH, there's a bunch of faucets on here. And we can give you some. Just send your address to Celine, and then she can either send it to me, or if she doesn't have enough, then I can help you pay for some.
Yeah.
And give you some.
Like on the chat, Discovery Basecamp chat, in fact, you have like a proper like topics related to Sepolia ETH, etc. So I can send like Sepolia base or Sepolia ETH as you want.
Cool. So I would say like if anyone wants to just have like stuff to take home, do what I did, go through, set up scaffold-ETH, try to deploy a contract, try to verify it and deploy it to IPFS if you can as well. And if you have time, you can check out Speedrun Ethereum, but you don't need to do this. This is not required, but there's a tokenization challenge that's pretty cool that you can do, and it doesn't take much time. It's really up to you. That's just kind of extra stuff you can do. Okay, I want to be respectful of everyone's time. I know we're at time. Any other questions?
You can have
You,
for tomorrow if you need to.
what's that?
No, I was saying like you can keep your question for tomorrow if you have to. Like I mean, if you have still some
Yeah,
question, don't hesitate to ask tomorrow. Kevin will be our main teacher during the week, so you will see him every day. Just tomorrow, Kevin is not here, so I'm doing an introduction to base. And yeah, all right.
cool. Thank you so much, guys.
You
Yeah,
want to or take a
sorry if it was fast. Yep, sorry, go ahead.
we can take a pic all together if you want.
Oh yeah, let's do it.
Like let's people put their okay, nice. Great, great, great. Um, I will let you know when I take the pic. I would say 1, 2, 3. And let's put some emoji. Nice. Okay. Wow. Let's wait a bit. Okay, amazing. So 1, 2, 3. Let's put emoji. Wait. Nice. All right. 1, 2, 3. Perfect. All good. Ah, Kevin, we can't see your face. Wait, because
Oh
the
no, really? Okay.
emoji.
Try one more time.
Wait. Uh, 1, 2, 3. Nice. All good. Perfect. Thanks, everyone. And yeah, see
Thank
you
you so much.
tomorrow and see you on Thursday with Kevin.
See you guys.
So just bye.
Thanks, Loki. Thanks, class. Yeah. Bye bye.